a parabola, but we're going to only look at one small part of it and zoom right into the graph. So let's just say it's sitting up here, right? And we want to find the gradient at one single point. Ordinarily, when you find the gradient, you need 2 points. Okay? If this was, for argument's sake, I'm not going to bother with the vertical translation, but if it was y equals x squared, and you want to find the gradient when x equals 2, okay? Ordinarily, you would need a second point, somewhere along here, and find the gradient between 2 points. Alright? But that's not what we actually want. The one we want is the one at this point here. Now obviously this is not zoomed in correctly. What we can do though, is we can get the gradient between this first point and the second point, and then get a third point that's actually closer to the first point than the second one. And all we say is we say that the gradient of the first line and the second line is tending towards what the gradient would be at that particular point. So if this was x equals 2, then we get y equals 2 squared, which equals to 4. So the first point there is 2, 4. Let's just say now we take another point a little bit further on, but not that much further on. If it's too far further on, then the gradient becomes really inaccurate. All right, so just a little further on, we're going to actually take 2.1, which is why I said we're really zoomed into this graph. Okay? When x equals 2.1, we get y equals 2.1 squared, which is 4.41. All right? So that point there, our second point is 2.1, 4.41. If you were to use y2, y1, x2, x1, all right, for that one, so we'll call it our m1, all right, so this is our m1 here, would be 4.41 minus 4 over 2.1 minus 2. All right, evaluate that, you get 0.41 over 0.1. Remembering, when you divide by a decimal, just move the decimal point over on both the top and the bottom, like that, so you get 4.1. Okay. Now we're going to choose another point even closer to the first one than the second one. So we'll say around about here somewhere, right? So it'll be like that. And the point I'm going to choose, we'll say is 2.01. All right. So that means when x equals 2.01, you get y is equal to 2.01 squared, which is 4.0401. Right? Pretty sure I should be right because I've done this a few times. So the third coordinates therefore would be 2.01, 4.0401. Then you do the gradient formula again. Right? And we'll call this one now, this one in here, M2. Right? So our M2, 4.0401 minus the original 4 over x2, 2.01 minus the original x. So we get 0.0401 over 2.01. Right? Basic subtraction. Move the decimal point over. You get 4.01. Can you see from the first line, you had a gradient of 4.1. From the second line, you have a gradient of 4.01. So that is very clearly tending towards 4. So what we would then say, and obviously this is a very tedious and slow way of working it out, but it's just showing you that eventually what you would get, the gradient at that singular point there, we would suggest would be m equals 4.